Hello, I'm John Klobuchar with InEight, and I'd like to welcome you to the latest webcast in our Planning, Scheduling, and Risk series. Today's webcast is titled, How You Win Before the Project Even Begins. Our presenter today is Dr. Dan Patterson, who is InEight's Chief Design Officer. In this role, Dan focuses on expanding upon his vision of creating next-generation planning and scheduling software solutions for the construction industry. Dan is a certified project management professional by the Project Management Institute. If you have any questions as you watch the webcast, please email them to webcasts@ineight.com and Dan will do his best to answer them. Also, this presentation is being recorded and we'll be sending you a link to the video in about a week's time. Once again, we're glad you've joined us, and now let me introduce Dan Patterson.
Well, thank you, John. Well, I'm very excited to spend the next 30 minutes or so sharing with you my thoughts on how contractors can reduce their risk exposure during the bidding phase of a project. So it's kind of interesting when you think about it. The bidding phase is probably the riskiest phase of a project. Get the bid wrong, then you're really carrying that exposure all the way through the project execution phase of the project, even before you've started the work. In many ways, it's actually less risky for a contractor organization to not win a job than it is to actually win the job. When you win the job, again, you're then marching to the agreed upon bid that you've put forward. Obviously, the flip side to not winning a job is you have zero upside and opportunity to actually make money commercially. So having said that, I think more focus and effort and really diligence around ensuring the bid that we put forward as a contractor, making sure that that bid is appropriate. I think we need to do everything we can to improve our confidence around that bid. So what I'd like to do is start off with a quick review as to really what I call a typical bid structure. Walk through how organizations today largely determine what their overall bid should be. Then let's take a little look at what we call anti-bid drivers. What are the things that could actually cause that bid to become commercially less viable? Then I'd like to introduce some risk analysis and risk modeling concepts that I believe are massively helpful in reducing bid exposure. And then let's talk a little bit then about how we can iteratively build on the bids that we put forward and use historical information to get smarter each time we embark on a new project. This concept of risk exposure and then risk analysis to overcome that risk exposure, I think it's very important to really note that risk is very different depending on whether you are an owner organization or a contractor organization. Embarking on a project from an owner perspective, what we're really trying to do is understand what is going to be our capital expenditure cost and how long are we going to have to carry that CapEx cost before the project is completed and turns into an operational asset. So the drivers from an owner perspective are very different to that of a contractor. A contractor is really looking to make sure that the bid price is realistic, and then during execution, try as best as possible to stick to that bid price. And so, it's my opinion that contractors are probably more cost risk sensitive, whereas owners are more schedule risk sensitive. Again, owners really wanting that project completion as soon as possible so as to convert that CapEx expenditure into, again, an operational asset. So during the bidding phase, again, I think historically many contractor organizations they do a very diligent, or they have a very diligent process in building up the bid package. Typically, they will first of all generate what we call a base cost. So in my example on the right-hand side, the $100 base cost, this can be either top down or bottom up. Typically, it's bottom up. That is the raw cost of executing the work. Now, on top of that base cost, typically contractors assign what we call a contingency. And again, I think typically that contingency is really nothing more than a fixed percentage. And, a 20% factor as contingency is certainly, well within the realms of normality for contingency. Now, on top of contingency, we have what we call margin. And really think of contingency and margin as working against each other. Contingency it's a buffer. It's accounting for the fact that if we have or incur cost overrun, we can go to that contingency bucket and consume some of that contingency. The remainder then is our margin. Now, what we're trying to avoid is the complete consumption of that contingency such that we get into really stage one, which is margin erosion, but stage two, and this is really sort of worst case scenario, if we consume not only all of our contingency, but also all of our margin, then from a contractor viewpoint, we become upside down on the job, which obviously is very, very bad. So contingency, again, as a fixed percentage is really, it's for covering risk and uncertainty. And then for things that perhaps are uncovered or we perhaps have no insight or knowledge about, that's when we get into margin erosion. Now, the concept of having base cost contingency margin, I think, is absolutely sound. Where I think, though, there is huge room for improvement is the calculation of contingency and margin, and also the relative amount of contingency in context of base cost, but also the relative amount of margin in context of contingency and base cost. So let's take a look at how we can perhaps achieve that. So traditionally, cost estimating, schedule forecasting, we've really been generating best case scenarios versus most likely scenarios. We put together a schedule forecast, and that schedule forecast may be based on standard productivity rates, but those rates, though, for example, don't take into account specific nuances about the project in question, whether it's geographical constraints, whether it's impact of weather, so on and so forth. And so I think all too often contractors, the forecast that they put together, they're really the best case scenario. And in the risk management world, we call that the P0. It's the best case. I think we should stop doing that, and instead we should be generating a range of outcomes anywhere from best case scenario to worst case scenario, so P0 to what we call P100. Then let's take a step back and say, okay, at what confidence level are we comfortable bidding? Do I want to be 75% certain that I'm not going to have margin erosion? Or am I a little bit more open to taking on some risk? Maybe I'm okay bidding at the P50 level. In other words, I'm 50% certain that there may or may not be some degree of margin erosion. So what we're doing here is we're now saying, instead of coming up with a single bid value, let's generate that range of outcomes, that P0, P100. Then we'll make an informed decision as to what we're comfortable with, and we'll then go forward with a scenario within that range that carries a given confidence level. So just a quick primer on how we actually build these risk-adjusted forecasts. Risk modeling, risk analysis has been certainly prevalent in the project management industry now for close to a couple of decades. While it may seem or sound somewhat intimidating, and the concept of Monte Carlo analysis and generating contingency and p-values and correlation and all of the statistical building blocks that we build into a risk model, at the end of the day, risk analysis is actually very, very straightforward. It boils down to simple inputs, an analysis in the form of a Monte Carlo simulation, and then intelligent interpretation of the outputs. With regards to the inputs, we first of all start off with our deterministic, again, going back to the concept of our best case scenario is really the scenario that doesn't account for risk and uncertainty. Onto that, let's then overlay those uncertainty variables and those risk events. We then run what we call this Monte Carlo simulation, which is really a brute force approach. It's a simulation of the execution of the project, and we're simulating execution of the project over and over and over. The reason being, what we're trying to understand is, what are all of the outcomes if and when those potential risk events and those uncertainties and things like quantity growths, if they indeed occur, what then could be our range? We then analyze the outputs, and I'll show you some of those in a couple of minutes. Uncertainty and risk events. These, while they both drive contractor risk exposure, the source of these two variables is very, very different. So uncertainty And quantity growth is really inherent during the iterative design phases of a project. So as we go from 30 through 60 through 90% design, it's very normal for those quantities to increase. And so we really should take into account the fact that we know those quantities are going to grow during those design phases. So the way we model that is by what we call uncertainty ranges. And in the most simplistic, we model using a 3-point estimate. So we forecast the best case or the minimum, the most likely, the maximum or the worst case. That then generates a range of outcomes. And it's that range of outcomes that gets sampled during the Monte Carlo analysis. Secondly, we also need to identify discrete risk events. And again, historically, risk events are stored in what we call a risk register. A risk event has a trigger. So in the event of X, this risk may impact our schedule and our cost forecast by Y. So risk events are very different to uncertainty. And really the key to accurate risk analysis isn't, or risk interpretation isn't the modeling or the results. It's getting these two inputs absolutely correct. Understanding what the uncertainty is, understanding what those discrete risk events are. When it comes to reporting, I think there's a huge misperception that risk models are, that they're fluffy, they generate all of these multiple outcomes. They're not fluffy. They are absolutely deterministic. The outcomes from the risk model are shown on the screen here. So let's explain these in a little bit more detail. On the left-hand side, what this is showing is for a given run. So in this case, let's say we ran 1,000 scenarios or 1,000 iterations. The computer is coming back with the outcome of each of those scenarios. Now, why that's so valuable is if we list those outcomes in rank order, as we can see on the right-hand side, we end up with what we call a range from P0 to P100. This is mathematically showing us every single possible outcome as a result of all of those moving parts, those levers pertaining to uncertainty and risk events. Now, how does that help a contractor when it comes to the bidding phase? Well, if a contractor can determine the confidence level within which they want to operate, and I would suggest, operating at a certainty factor of no less than 75% is reasonable, we can reverse calculate the scenario given that confidence level. Okay, so at, for example, a 75% certainty, we know that our project completion date, as the example shows on the screen here, is the 13th of February 2024. That's very different to the original deterministic date of the 21st of December 2022 that we had in our initial schedule. So what we're able to do now is make an informed decision and say, okay, if we want to adequately take into account risk and uncertainty, we need to bid with the expectation that we're going to finish in early 2024. Now, if we look at that date, and we could do exactly the same thing for costs, but if we look at that date and we say that is just not commercially viable, then we get into what we call proactive risk reduction or mitigation. And on the right-hand side, the risk tornado chart gives us a view as to what are the areas and the key risk events, what are the risk hotspots we need to pinpoint and mitigate in order to accelerate that early 2024 date back to that late December 2022, early 2023 date. Let's now look at how that relates to cost and cost bidding, again, from a contractor perspective. Again, I think historically, contractors have focused on generating a single value bid. So the example on the screen here in the table on the right-hand side, the contractor example here, base cost of 100, let's apply our 20% contingency, our 15% margin. Okay, that's great, but we have no idea how certain that bid is. How much confidence do we have that we've applied sufficient contingency? What is the probability of eroding into that margin? Well, now we do, because as a result of running the risk analysis, we now have what we call our P10, 50, 75, 90, 100. We've got those 5 different scenarios. And what those scenarios are showing us is the P10 is really the almost mathematically best case scenario. And it's really interesting because what it's showing is in the best case scenario, our $100 base cost, we only actually need an additional $4 of contingency. That would net us a margin of a whopping $32. Well, that's over double what we originally thought when we put our bid together. Now, moving from left to right, if we look at our 75% certainty, our $100 base cost will demand $14 worth of contingency, again resulting in $21. That $21 margin is still greater than the margin we thought we were going to walk with when we looked at our initial bid. Now, going all the way to P100, P100 is the absolute worst case scenario. P100 again is very interesting. Against that $100 base cost, it's suggesting or indicating that we actually need $50 worth of contingency. Now, that $50 worth of contingency against the $20 that we originally allocated would result in negative margin on this project. We would commercially lose money in that particular scenario. So, if I'm the estimator responsible for putting forward the bid package here, I would look at this range of outcomes and say, as an organization, typically we wouldn't embark on a project endeavor without a certainty factor of less than 75%. At 75%, I am confident that we will only need $14 of contingency, which results in a $21 margin. Now, if I think that is perhaps a little on the perhaps the greedy side, that then gives me an opportunity to reduce my margin, still have the confidence of not getting into margin erosion. That makes my bid cheaper and arguably more competitive. So it's this kind of insight that I think is really proving to be massively valuable to contractor organizations. I'm still bidding at a single deterministic point. I'm going in at my 75% certainty, but now, in my back pocket, I have this certainty factor. Not only that, I know the sensitivity of my $14 contingency and how sensitive that contingency is relative to my margin and margin erosion. So one of the challenges, with risk analysis, I've shown you what I believe are really the benefits of risk analysis. One of the challenges is building an accurate model. And really an accurate model boils down to gleaning those uncertainty and those risk event inputs. And honestly, historically, this has been a real challenge. In the last 18 months, I think we've made a massive step forward in overcoming that complexity. And the way we're doing it is through a combination of what we call artificial intelligence and human intelligence. What we're doing now is we're storing historical project information, whether it's bids that we won or even bids that we lost. We are storing that information in a knowledge library, and we're now leveraging artificial intelligence and what we call an inference engine, where the computer now is able to go back and interrogate the bids that we won, the bids that we lost, and come back with patterns and say, okay, for this particular type of project, this is the percentage that was applied to contingency. This was how much margin. I think secondly, the concept now of coming up with these 3-point estimates for uncertainties and having to brainstorm against a blank sheet of paper for risk registers, those days are thankfully gone. And what we're able to do now, again, is leverage historical information and also more easily leverage our stakeholder information. So from a contractor viewpoint, there's an example here on the screen where I, as the bid lead, what I'm doing is I'm actually saying to my team, hey, can you give me feedback on the bid? And I don't want you to get into 3-point estimates and ranges. I simply want you to vote. I want you to use this scorecard, as you can see on the right-hand side. Now, if I can get multiple contributors to give me feedback, those contributions themselves can automatically become, behind the scenes, those ranges, those 3-point estimates to feed into my risk model. So I think finally, we're realizing now that yes, Monte Carlo analysis and uncertainty ranging, it is absolutely the correct way to model risk, but the way in which we capture uncertainty and risk, we're now realizing there's a much more human and easy to understand way to do that. This concept of artificial intelligence as well, I think it's worth elaborating on. So on the right-hand side, an example here where as I'm putting together my bid package, having the computer guide me or make suggestions to me as to risks that occurred on previously analogous projects. Well, this is very, very powerful, because what it then enables me to do is make an informed decision as, yes, actually, local regulatory authority changing requirements on me. You know what? My project is absolutely exposed to that type of risk. I want to account for that in my bid package. So having the computer make those suggestions, certainly if I'm a cost estimator or a scheduler that perhaps hasn't got as many years experience as perhaps other more seasoned project controls people, then I can still come up with a very accurate bid, leveraging that historical information through artificial intelligence. So this is an example of a bid package. This is a schedule that I'm putting together as part of my contractor bid. And again, I think what's very, very powerful is the fact I'm actually seeing the impact of my potential quantity growth and risk events in real time as I'm building the plan. If I drill down through my engineering, procurement, construction scope, this is a vertical build project. So I'm on floor 1, interiors. I'm looking at the plumbing rough-in. I can see that this particular activity, while I planned for 23 days, the computer is suggesting it would actually take over double that time. And the reason for that is the team are pushing back on some of those durations and productivity rates, as well as identified risk events as well. And so I can see not only the risk-adjusted durations, I can also then, in the big picture, I can see the knock-on effect downstream in my schedule. So again, I'm looking at this within the lens of a given confidence level. The colored bars in the Gantt chart here are, in this example, my P75 scenario. So much more insightful and honestly much more realistic than just looking at my best case deterministic. With this, this concept of now doing a Monte Carlo simulation and determining the range of outcomes, and then saying, okay, at what confidence level do we want to bid, and then picking the scenario that matches that confidence level, we're starting now to see some trends with regards to percentages for contingency and margin. And I think what's really interesting is on the smaller projects that are less than $1 billion capex, the amount of contingency required is significantly less than projects that are over $1 billion. So in the case of the sub-$1 billion capex price point, typically adequate contingency is sitting at about 4 or 5%, with margin being over double that. Now, conversely, when we look at the absolute mega projects over $1 billion, the amount of contingency required, again, at that P75 certainty is almost 3 times that of the 4% that we saw on the left-hand side. It's sitting at 13%. I think what's very interesting here is, this is a result of the fact that those mega projects, there is so much complexity and so much independency between various subcontractors, and there's numerous constraints and weather and so on and so forth. What the risk models are showing us is there is different amounts of contingency that should be applied based on size of project. And again, I think if nothing else, the insight that this risk analysis is starting to bring now, we didn't know these benchmarks or these trends prior to doing this kind of risk analysis. I think another very interesting eye-opener is the correlation between time and money, and certainly with regards to risk exposure of time or schedule and risk exposure of capex dollar amount. So by tying the two together, what we're able to do is, as you can see on the right-hand side, is we can see the correlation or the relationship between risk-adjusted schedule and risk-adjusted cost. And what's very interesting, in many cases, when we risk-adjust our schedule and risk-adjust our cost forecast, in the early phases of the project, our spend, our risk-adjusted spend, may actually be less than what we thought our spend should be. And so, you might think, well, that's great. No, it's the complete opposite, because what's happening is the compounding or the cumulative spend is shifting to the right. What it means is, yes, we're underspending in the early phases of the project, but that's going to bite us in the back end of the project when those delayed cost incursions kick in, and we end up with not only a cost overrun, where the project costs us more money than we initially thought, but the time it takes to execute as a contractor is also greater than our initial schedule forecast as well. So understanding, the relationship between cost and schedule risk, and then looking at the inflection point between our risk-adjusted forecast and our, what I call the deterministic, again, I think is a very valuable insight. So what we've walked through is really a three-pronged approach to reducing risk, certainly from a contractor perspective. When I think about, using artificial intelligence or augmented intelligence, having the computer mine historical knowledge and come back with really a sanitizer or a validator as to, well, these are the actual historical productivity rates that we were actually able to achieve. These are the benchmarks against which we should be bidding, I think is a massive step forward. The concept of human intelligence, again, being able to collaborate during the bidding process and take our stakeholder expertise and incorporate it into our risk-adjusted bid, again, I think is a huge step forward. And then, this concept of building or having insight into risk exposure during the development of the schedule and the cost estimate itself, this is something that we've not been able to do before. Typically, or historically, this science of risk analysis and Monte Carlo analysis, we would have to hire a third-party risk guru to come in and do their fancy risk modeling. You don't need to do that anymore. With the merging now of estimating and scheduling and risk analysis, the ability to account for uncertainties and account for risk events and see that in real time is just so valuable. So I hope what we've walked through has been, insightful and worth your time. I think if nothing else, what we're doing here is we're providing tools and a framework to give you, the contractor, an opportunity to not necessarily come up with a more competitive or a cheaper bid, but to come up with a bid that is more realistic and one that carries a higher confidence value. At the end of the day, I really think it's more down to, or project success is more down to having confidence in the forecast that we've agreed upon versus going in as cheap and as fast as possible. So again, I hope this was an insightful webinar, and thank you all very much for spending your time.
Thank you, Dan. Again, if you have any questions of what you've just seen, please email them to webcasts@InEight.com. To learn more about InEight, as well as our planning, scheduling, and risk solutions, visit InEight.com and click on the Request a Demo button. And if you'd like to see a schedule of upcoming webcasts, visit InEight.com/webcasts. Thank you for watching. This concludes our presentation.